As you look at your packet on reaction predictions, and look up here at what I have on the board. First of all, check number 1 out. The very first thing that you should see written after your number 1 is 2 elements yield a binary compound. Number 2, you should see a nonmetal oxide plus water yield an oxyacid. See how this sheet corresponds with what you have on your outline. You see the similarity with it? Somebody nod their head and say, yes, I see that. Okay, good, good. Just making sure people are alive in here. All right. This document right here will be something that you will be given when you take tests and quizzes on this. So, this is what we refer to, and I even have it, the helper sheet for reaction predictions. So, you will have this in your hands when you are taking tests and quizzes. So, it will help you, but it will not tell you everything that you will be doing. Okay? So, you will have this at your disposal when we take a test or a quiz. So, if we look at that, we talked about the first 2. The third one, an active metal oxide and water, a metal yield a metal hydroxide. The fourth one, a metal plus oxide will yield a metal oxide, or metal plus oxygen will yield a metal oxide. And then finally, ammonia plus acid will yield an ammonium salt. And we should by now understand what ammonia is, NH3. That was one of the things way back when in bonding that I told you, well, you know, you really need to memorize that. Okay? So, reaction predictions. As I told you yesterday, reaction predictions are not easy. It takes a lot of mental work. It takes some memorization of what exactly is going on. So, you should have watched the video. You should have went through some examples. Okay, so what we're going to do is we're going to work a few more of these examples, and then I'm going to give you a worksheet. So, with today, our objective should be to be able to take reactants and to predict how they would form in a combination reaction. So, I'm going to switch right here, the very first one. Let me hide that so we're just focusing on this one. I look right here and I say, okay, what one of the 5 combination synthesis reactions am I dealing with? What one of the 5 am I dealing with? Rachel? The fourth one, Rachel says, a metal plus oxygen yields a metal oxide. Would we agree with that assessment? And it tells us right there what? We need to check the activity series. All right. So, let me get out my activity series. I don't know where it is. It should be over. Oh, I just saw it. As I take out my activity series, it's great to check it, but what am I looking for? What am I looking for? Anybody know? What on that activity series tells me anything? What'd the video tell you to do? Go ahead and take out your notes if you need to review your notes, some too. Okay? What do we need to check on the activity series? Excellent. Find copper on your activity series. Point to copper on your activity series. To the right of copper on your activity series. Okay? You know what? I'm going to pull one up here too. I'm going to pull an activity series up too. It's that easy. Okay? Right here I am on my activity series. I wish it would move. Come on. Right here I am on my activity series. Right here I am frozen on my activity series. There we go. If I look right here is copper. I have copper right here. It says right to the right of copper reacts directly with oxygen, giving oxides. So I go back to my problem and say, okay, aluminum plus oxygen. Is aluminum above that line? Is aluminum above that line? Yes, it is. So I am going to have this reaction occur. So I've come to terms with aluminum will react with oxygen to yield what? To yield what? A metal oxide. Now here's where it gets a little touchy. You know what people immediately want to do? They want to do this. They said it's going to yield a metal oxide. And they do that because they say, okay, I've got one aluminum and I've got two oxygens. Now I've got a balanced equation. What do we know about charges, though? Do those charges right there match up? No. So that is not aluminum oxide. So what I tend to do when I'm dealing with this is I actually think in my head, all right, when I form my metal oxide, it's going to be aluminum oxide. How would you write the formula for aluminum oxide? You go back and you look at what? Charges. What's aluminum's charge? +3. What's oxygen's charge? -2. So what is my formula going to be? Al2O3. So now I've got my aluminum oxide up there. What's the final thing I need to do? What did we do yesterday? Balance. Okay? Is this a balanced chemical equation? No, it is not. So I need to go through and balance this equation. When I look at this, I say, okay, my problem, first of all, is going to be the odd and the even oxygen. So I need to make this an even oxygen. So now I have 6. Now I have 6. And that would leave me with 4 aluminums. So my balanced chemical equation for this combination reaction would be 4Al plus 3O2 yields 2Al2O3. Moving on. Here's my next one. Go ahead and write it down, and let's identify which one of my 5 combination reactions is this. Which of the 5 am I dealing with? Anyone? Anyone? Parker? Okay, let me ask you this. Is calcium a nonmetal? Calcium's a metal. Okay? So you're telling me what? Number 3, an active metal oxide and water. Okay? So I'm dealing with rule number 3 here, an active metal oxide and water. I look at my active metal oxide and water on my outline, and it tells me what? That active metal must be a group 1 or a group 2 metal. Is calcium a group 1 or a group 2 metal? Is it? Absolutely. So, will this reaction occur? Yes. So, I am going to be forming a metal hydroxide, specifically what metal? Calcium. So, what am I going to be forming? Calcium hydroxide. Now, how am I going to write the formula for calcium hydroxide? Ca, what's hydroxide? OH. Is that it? Is that calcium hydroxide? You're shaking your head. Why isn't it, Ethan? Okay, calcium is a 2+ charge, hydroxide's a 2-, so I need to have the parentheses, or excuse me, hydroxide's a 1-, so I need the parentheses 2 to have my charges balance out. So I've got calcium hydroxide. I'm going to get that out of there. So, is my equation balanced? Yes, it is. Yes, it is. So, am I done with that one? Yeah. Yeah. I'm good to go. My third one. Let me get that up a little bit more. My third one here has N2H, or excuse me, N2O5 plus H2O. Now looking at my synthesis, or excuse me, my synthesis combination reactions, okay, how many of them are dealing with water? 2 of them. So I've already got this narrowed down that, and I forget what numbers, where's my papers, it can only be 2 or 3, right? Can only be 2 or 3. Which one is this? Is this 2 or is this 3? It's number 2, right? Because I have a non-metal oxide with water. And that tells me that I am making an oxyacid. What in tarnations is an oxyacid? What is an oxyacid? Nobody remembers oxyacids? You said an acid with what? Oxygen. Well, that's a true statement, but we need to go a little bit more in depth. Okay? An oxyacid is an acid that has oxygen and some other element, usually, but not always, usually a nonmetal. So if you would look at your PAL, your polyatomic ion list, anything that's a polyatomic ion that has oxygen and some other element has the potential to be an oxyacid. Now, in this case, what are some polyatomics on your PAL that are dealing with nitrogen and oxygen that could form an oxyacid. Anyone? Okay. The first thing that comes to my mind is nitrate. Nitrate is NO3, and what's its charge? 1 minus. So what would the acid be of with this nitrate? HNO3, and that would be nitric acid. So I have my oxyacid that is formed. Am I balanced? Am I balanced? No, I am not. No, I'm not. What do you think my problem is going to be here, just looking at those? Is oxygen a problem? Really, about everything's a problem, isn't it? None of them are balanced there, okay? I would look, though, here and start out with my oxygens that I look on this side and say, okay, here's 5, 6. I have 6 oxygens. How am I going to get 6 oxygens over here? By adding a 2, correct? Once I add that 2, guess what? Everything works out, doesn't it? I add that 2 and everything works out. We okay with that one? Okay, let me pull down another one. Pb plus Cs. Lead plus cesium. As I look at my 5 combination reactions, which of the 5 is this going to be? Well, number 1, we can rule out 2 and 3 because there's no water. Is this a metal and oxygen? Nope, it's not 4. Is ammonia on there? Nope. So this has got to be number 1 just by process of elimination. And I look at number 1. Number 1 states that 2 elements yield a binary compound. A metal plus a nonmetal will yield a salt. A nonmetal plus a nonmetal will yield a molecule because that's covalently bonding. Except 2 metals are no reaction. Now, as I view this, do I have a metal and a nonmetal? No. Do I have 2 nonmetals? No. What do I have? 2 metals. So what does my outline tell me about 2 metals? That it is NR, meaning that there is no reaction. This reaction will not occur. So I just simply put NR. Okay?